Hi, and welcome back to day 6 of the TDD PHP spec Advent of Code. Today we've got day 6, probably a fire hazard. The idea here is Santa's got us a grid of 1,000 by 1,000 lights with coordinates running 0 through 9999 in each direction. So the corners of our light grid are 0, 0 going all the way to 999, 999, and the other corner would be 0, 999, and 999, 0. And then he's given us this big list of instructions for the ideal lighting situation. And the instructions can consist of turning on, turning off, or toggling a group of lights with rectangular coordinates. So on the screen here is my input file, or part of it. And this is what we'll need to be parsing and feeding in order to control the grid. So we want to, at the end of this, determine how many lights are going to be on total at the end of all of these operations. So in order to do this, what I want to do is go ahead and simulate the grid and simulate some lights and have it run through all of the instructions that we need in order to do that. So I'm going to have a grid class and a light class and probably an instruction parser class that's going to read in each line of instructions and tell the grid what to do with the lights. So let's get started. First of all, I think I'm going to start this time with the grid. So let's do phpspec describe day 6 grid, and we'll run that with phpspec run spec day 6. And create that, please. So we now have a day 6 directory with our spec, and we have a day 6 directory with our code for grid. So the first thing I want to do is I want to say, let's build, how are we going to build this grid? And I think if we build it with a limited size, maybe it'll be a little bit easier to test for one, but the size shouldn't matter as far as how the thing works. It's going to be an XY grid of lights. So let's see, I need a height and a width, and let's say we'll do it with the prototype pattern. So we'll have a let. So do public function let, and we will construct it with light interface. Light. I need some dollar signs and some lowercase there, and that'll probably work a lot better. So dollar little light, and we'll do, let's say for testing we're going to do a 10 by 10 grid. So we'll do this be constructed with 10 by 10 and light. So it's going to pass into light, and then I'll show you what I mean by the prototype pattern here shortly. So let's run that. And it says we don't have a light interface, which is correct. What was the problem? There was something I have to do in order for this to generate properly. Oh, I know what it is. So because I'm in this namespace spec day 6 light interface, it doesn't know what I'm talking about. So I need to make this an actual day 6 light interface. And at this point I can tell phpStorm, go ahead and import that class, which makes it short and adds the use, and now we'll be good. Create the light interface, create our constructor. Let's go back into the constructor, and the first parameter is going to be our height, or width, it doesn't matter. We'll say width. And then second parameter is going to be height, and we'll spell that correctly for spelling reasons. And then this is going to be a light interface, and it's going to be our light. All right, and now we need to make some constructor problem things go on. So in our grid, it's going to be, like I said, x, y coordinates, x for width and y for height. So we'll loop over this, and we'll say x starts at 0, x is less than width, because width is our number of light bulbs in the x direction, and then x plus plus, and then we'll loop over our y's. We'll do y starts with 0, and y goes up to, but not including height, and we'll increment y. And then we're going to initialize our grid in the xy space. So x, y, we'll do a two-dimensional array, and it's going to be equal to a clone of our light. So instead of newing up a bunch of lights every time, we're going to have one light, and then we're going to clone it every time, which is kind of our prototype pattern. So we're only going to actually build one light. So I've now got a little light bulb on this line, probably about grid. Let's find out. Nope, it's not about grid. Let's go to grid, and we'll add the field, create the private field. Now we have a grid. We also need to probably keep track of height and width. So let's do initialize fields, and let's do height and width, and it adds those. So now we've got a grid that's going to store our actual data, or actual light objects, and that's all we need. So let's run that, and that should be working because we're not really testing anything about the constructor. We're going to be testing things about what we want it to do. So one of the things we want it to do is we want it to be able to do operations on our grid, right? So we've got our instructions that say toggle or turn on or turn off, and then we're going to always have a start x, y, and an end x, y. So let's write a little bit of spec on that one. So we'll say public function, it can do operations on the grid. All right, and we're going to say this do operation, and we will say let's do a turn on operation, and we'll say it's going to start at 0 and 0, 0 and go to 1, 1. So that should be 4 lights that are going to be turned on, and we'll say this get lit light count. That'll be our other piece that we need. Should be 4. So out of our 10 by 10 grid, we've now lit up 4 of them. Let's say it can do, we'll just separate these out. It can do turn on operations on the grid. And now we'll do another one that'll be based on the same bit, but we're going to turn some off. So we're going to say turn on 0, 0 to 9, 9. So we're going to turn on the entire grid. The count at this point should be 100, and then we want to do another operation, do operation turn off. And we'll turn off, let's say, 1, 1 to 9, 9. So everything but one column. And now our get lit light count should be 90. All right, and this will be, it can be turned off. All right, and now let's do a toggle. So we'll have, let's base it on the same thing again, right? Let's copy this one. Right, so now we've got a bit in the middle, so we've turned on everything here. Then we get our lit light count. We turn off everything but a column, and actually let's leave 2 columns on. So we'll go just to, that's not how that's going to work. All right, let's see if I think I've messed up on this last one. Shouldn't be 1, 1 here. It ought to be 1. We've got x and y. We're going in the x direction. I think just 0 again. Right, so we just move in 1 column. And this one, same kind of thing. This should be 0. This is 9. This is 9, except we want to move that back 1. So we're going to do up to 8, 9. So 1, 0 to 8, 9. If I'm doing this math in my brain hole properly, then that should leave 80 lights turned on. And then we want to do a toggle. Do operation toggle. And toggle will go from, our x is going to be 0. Our y will do it 5, and we're going to go all the way over to 9 on the x, and we'll do 6. So we should have turned on a bunch in the middle, and or sorry, turned off 2 on the sides, and turned on like 8 in the middle, or no, 16 in the middle, something like that. Crap. Math is hard, man. All right, we'll take a look. I think maybe we'll come back on this, right? So we'll say it can do turn off. This is not turn off anymore. This is toggle or toffle. It's a totally different operation. We'll do that later. For now, I'm gonna get rid of these. Just comment them out. Let's run this. Do operation get lit light count. All right, so we've got our do operation turn on. Our grid is going to take in our operation, our start, was it start x? Yeah, start x, our start y, end x, and end y. Okay, and we want it to turn on and off the lights as appropriate based on the operation. So I think our operation needs to probably be transformed into an operation that we will do directly on the light bulb. So turn on, turn off, and toggle on a light bulb is going to be what we want there, which we haven't defined it yet, but we will probably soon. Our get lit light count is going to be running over the grid and counting how many lights are on. So let's do a different test first. So before we get started there, so I want to get as simple as possible to start with. So we'll say public function it is all off to start. And if it's all off to start, then we're going to have, let's do a, let's pass in our light bulb, right? So our light bulb, light, no, it's light interface, light, and we're going to have the grid ask each of the light bulbs if they're on and off. So we'll say light, and we'll call it is on, should be false. So all the lights are going to answer the question is on with false, and we'll say this get lit light count should be 0. All right, and let's run that. And it says we don't have that on our interface. That's fine. We haven't made the light bulb yet. So call to undefined should be on this one. So this get lit light count should be 0. Why is it fussing at me here? Get lit light count. All right, we got our this. We've got our lit light count. Get lit light count. Sounds like Fox and Socks here. All right, we've got should be 0, and it's telling me that we're calling this should be as an undefined thing. You know what? Let's see what happens if I get rid of this. So we'll call get lit light count. Let's get rid of get lit light count. Let's run it again. And it still does not like that. All right, this get lit light count should be 0. All right. Let's try it slightly different maybe. Should be 0. No, that's the right one. Should be still is not liking that. What did I do wrong? This get lit light count should be 0. What can it be? Let me pause and I will come back as soon as I finish figuring out what in the world it is. All right, we're back. For me, that was a couple of minutes. For you, not very long. Sorry about that. But here's what the issue is. It's not the should be here, it's the should be here. This is a prophecy, and that should have been my clue there. But the idea is not that we want this interface that we're defining the behavior for to should have some behavior. We're saying, what is it going to actually be? So in that case, I wanted to use will return. I get caught up on this one every once in a while, but it's something good to be aware of. So when you're defining what behavior should be, instead of should, it's will. And if you're expecting behavior, then it's should, because we don't know what the behavior will be. So now it says, do you want to create get lit light count? I deleted that while I was thinking, so let's get rid of that. And we'll come back in here. We'll say, all right, get lit light count. It should be 0. Let's make it 0. Let's run it again. Hooray, everything's fine except for nothing can turn on ever. Let's make another function real quick, or another test rather. So it is what? Let's say it will be all lit if lights are all on, right? So in this case, I'm going to pass in the light interface, light, and instead of having it return false all the time, if we say it's on, we'll return true. Now we're saying all of these, we're essentially building the grid and everything is going to start out as on, so we should be able to count those. So we'll do get lit light count should be 100 because we've got a 10 by 10 grid. All right, and this should fail because I have a dumb implementation here in grid. Now I need to actually run through and build a real function. So let's do count is 0, return count, and we need to run over the grid. So we're going to say for x is 0, x is less than, you know what? This looks almost like this function here, so to save a little bit of time, let's copy that bit over there, we'll paste that in. And now we're looping over this. We need to go for this width and this height. And instead of cloning the lights in there, we're going to, if this grid x, y, and that's going to give me a light bulb, is on, then we're going to count it. Count plus plus. So we're looping over all the lights. We're saying, are you on or off? If you're on, then tell us true, which means we count it. If not, then we don't. And that makes our test pass. So now we've got, at least it's working for everything is on and everything is off. What we need to do now, assuming that I've done the get lit light count, is start turning on some of these other tests that we wrote a moment ago. And let's make sure we can turn everything off. So our default light that was passed in will turn on all of these lights. So it'll do this operation. Let's see, do operation should turn on all these lights, and our lit light count should be 4. Let's see, does this make sense? We've got a bunch of cloned lights. We've got our operation that's turning on stuff. I'm not sure if this makes sense. But now that I'm doing it, I'm not quite sure what I would do differently. So we've now got this operation. Let's go ahead and build it out. Our operation says take an operation. That'll be our string that tells us what we're going to do. We'll do a start x and a start y and an end x and an end y. All right, and now we have it. It fails. Okay, so if our operation is turn on, we want to loop over some portion of the grid and get a light count, and it should be 4. Get lit light count should be 4. So is that really what we care about? I don't know. If I put some behavior on the lights, I want to make sure that 4 lights were told to be turned on, but I don't know. I don't know what the right way to do this is. So we'll build our light interface, our do operation, our light. Again, I'm at a loss here. I'm not even joking on this one, but what I want to do is say our light turn on should be called times 4. So 4 total lights should be called from the do operation. And get lit light count is not what I care about. So I'm going to get rid of that because that's assuming we actually have lights that are paying attention to what's happening. In this case, we have fake lights. Let's see what happens. So I had to turn on to the light interface. It says we didn't make this call 4 times, so we need to make the call 4 times. So I'm going to try making a call 4 times and see if that makes it work. And if it does, then we'll be in a better place. So we'll say this grid 0, 0. This is a really dumb way to make this pass. Turn on. And honestly, not even sure if it will make it pass, but we'll try it. Okay, it does make it pass. So that means I think I'm on the right track as far as how I would actually test this. Not exactly sure how I would test it exactly to make sure that it's doing it on the right operations, because that's all kind of internal functionality inside of our grid that we don't necessarily need to expose. But what we want to do on the operation is we're going to say, all right, let's figure out what is our light, our light operation. Right? So our light operation, we call it turn on, and we need to map that, right? So we're going to have operation map, I guess. Map. And we'll say that's an array from what we pass in from our operation there to the name of the method on our actual light bulb. And we'll add the other ones later as we need to. And then we're going to do this same loop. Almost all of our stuff in here is going to loop over the grid and do stuff to it. So I'll paste that in, and instead of counting it now, and instead of checking if it's on, we're going to actually call the operation on the light bulb. So we're going to say this grid x, y, and let's get our method. I'll just make another variable just to make it a little bit simple. We'll call it method equals operation map, and we'll pass in operation. That should get us to a method, and we'll call method using the $, so make sure we actually call the variable name method, and we'll loop that. That should call 4 toggle or 4 turn on things. All right. Oh, you know what? That's totally not what we want, right? So it's almost the right one. It's not quite the right one. So I did the entire grid, and it's telling me here, look, I called turn on like 100 times, and I expected only 4, but that's because I copied this and didn't actually make it work. So we want to make it go from start x up to and including this time. So we're not doing a less than, we're doing less than equal, all the way to end x. And then we're going to go from start y all the way to y is less than or equal to end y. Oh, this is not, I did this backwards. So y starts at start y and goes up to end y, including end y. And there we go. So now we got 4 turn on operations. Our next one means that actually, okay, this is where my problem was. I'm thinking about this way too much as everything is all put together. All I care about on the grid is that I've done the operations properly. I guess I sort of, it seems to me like I would still care a little bit about which light bulbs exactly I turned on, but maybe that doesn't matter yet. So what I care about though is the operations. So I've got this operation turn on. I don't care about that. I've already done it. I don't care about lit count, but I want to do from, let's say, turn off should be called on here. We need a light bulb so we can check our light interface, light, that's the ones that passed in. We do the operation turn off from, let's say, 0, 0 to 5, 5. So we've got 36 lights that are going to be turned on, and we'll say light turn off should be called times 36 with a 3. All right, let's run that. And it fails. It says we can't do that. There's no turn off. So we haven't mapped turn off, which is okay. We can map that now. We'll say when we pass in turn off, then that becomes turn off with that. We'll run it again. And it says we don't have light interface turn off. Do operation turn off should be called times. So last time it told us, do you want to make this? Why does it not tell me that? Light interface light, that's all the same. Do operation turn off from 0, 0 to 5, 5. Why would you not be there? It's a mystery. Turn on is on. Both of those are there. All right, I apologize again. I'm going to have to pause and see what I'm thinking of. I'm having some problems here. Be back in a bit. All right, I'm back. It didn't take that long, but I apologize for that pause as well. So here's the issue. I think from before when I built some stuff, it created bits on the interface that already existed, and then I proceeded to do the next two tests, so including the one we just did. Turn on was already there from something else, probably from the earlier time, but I really need that to be before the operation. So if I switch this and run this, it will tell me that it can create the turn off thing for me. In that case, everything is fine and we're all good to go. So because I'm calling it as should be called instead of should have been called, it's expecting me to do that before, and I didn't do that, which means I'm not totally sure why this worked properly, but it did. And probably because it kept track of how many times it called, but it didn't work as far as actually generating that thing that I needed. So let's go back to toggle, and again we can make this simpler, I believe. So we'll get rid of all of this junk, and we're going to pass in a light. And we'll say the light toggle should be called times, and let's do 25 times, and we'll say this goes from 1, 1 to 6, 6. If my math is correct, then that's 25 times. We need to add the light interface toggle. Yes, please. We don't have that as an interface. So we need to add that one, or we don't have it as an operation map. So we'll do toggle, and that maps to toggle. Okay. And how many times did we call it? More than 25. We got 36, so my math was wrong. So let's go back here, 1, 1 to 5, 5, because it's inclusive. That's why. Should have seen that with the one above. There we go. So we've now toggled 25 lights. We can get our light count. I think that's probably working. I still don't have a good idea of having a test where the only exposed bits in our grid are this do operation and get lit light count, because I don't have access to directly manipulate the grid, but I do need to have some lights respond differently than other lights. That may be something that we can set up with phpspec, where we say, hey, the first 25 lights should say false when you ask them if they're on, and then the next 75 should say true, and then our total should be 75 or something. I'll do some research after I do this video and see if that's possible, and then I'll report back or update the GitHub or whatever. But for now, we've got a grid, and I'm okay with it. So let's build a light. So we got phpspec describe day 6 with a light, and we'll run it, create the light. Let's go open up those files. So we've got our light spec, we've got our light code, and our light spec. So somebody commented that we have another function that I should be using here called it should implement. So we're going to do that. So we're going to say it should be a light interface, and we'll do this should implement that class. We'll go back and tell it what class that means. Light interface is the one. So it turns out that should be and should return and should implement and a couple of others all mean the exact same thing, but as was commented, it actually is more clear about what the intention is. So should implement implies that we're talking about an interface as opposed to a class extension, although both of them work as far as is a relationship or a interface of or instance of question. So says it should be an instance of light interface, but instead we just got the normal light, so we will go ahead and implement that guy. Implements light interface, there we go, and tell it make some stubs. Now we have our stubs. We run, everything's happy. So now we need to test it, and we need to write some specs so we actually have some code. So we're going to say the light should be off by default, so public function it should be off by default. So this is on should be false. And it's not, it's null. We'll go back to our light, and is on, return false, run, everything's happy. We'll come back in. It can be turned on. This turn on. This, and now once we've turned it on, should be true. We'll run that. It says nope, you fail. So now we need to actually have some kind of a variable for our state. So we'll say return this state, because not creative right now. And I'm going to add that as a field. Private field up above says state, and we run it, and we now have two failures. So I actually caused a regression on the should be turned off by default, and that's because there's nothing instantiating this light bulb that's going to turn that to false by default. I can put that right there. I don't need a constructor, and we'll run again. That part works, but now we can't turn it on, so we need to be able to turn it on. So we'll do this state equals true, and we'll run it, and hooray, everything's fine. So I'm using a Boolean. I could use something else. We could use something that says on or off or whatever. It doesn't really matter. All of that is internal. As far as our test is concerned, it doesn't actually matter what we use there. So we'll do it can be turned off. So I'm going to copy the guts out of this one, paste it in here, so it's now turned on, and then we're going to turn it off, and this is on. Should be false, and it is not, because we turned it on and then light doesn't have any way to turn itself off. So we'll say this state equals false. Run it, everything's fine, and now we have our final bit. We need to get our toggle to work, so we'll do public function, it can be toggled. So we'll toggle it. Say toggle. This is on. Should be true. This toggle and it should be false, and this should fail because we haven't implemented it yet. Let's go back over to light. Let's make it happen. So this state equals not this state. There we go. So now we have a working light bulb, we have a working grid, and we now just we need to have something to parse instructions into our grid. So it's going to take a grid in, and it's going to read in an instruction, and then it's going to tell the grid to do the instructions. And let's get that created. So we're going to do phpspec describe, call it day 6, and we'll call it instruction parser. We'll run, create the instruction parser. So now we've got a class, and we're going to instantiate it, and we'll have it run. We'll have it run the instructions, right? We'll have it run the instructions, turn it into calls that we can use on our grid. So we can do this a number of ways. We can say the instruction parser is going to take a grid and it's going to be operating on the grid, or we can have the instruction parser doesn't know about the grid, but it's going to return back the valid information, or the important parts from our string of instructions from our input text. And we'll probably let's go that way. We'll make it completely separate from grid. It's not going to know about grid at all. So we'll open up those the spec and add public. All right, so we'll say it can parse a turn on line, for instance. So we'll say public function it can parse a turn on line, and we'll say our line is, and I'm going to copy a real one out of here. We'll say turn on, there's one, and we'll go back to the instruction parser spec, paste that guy in. All right, and now we want to do this parse line should be, and let's have this return an array of instruction parts. So pretty much the instructions that we're going to need to run the grid. So it'll be giving us back turn on, and then it will give back start x, which is 66. Will be 668 and 20, comma, and then 935 and 470. So it's going to give us back this array with the stuff in there that's the important parts that we care about. Let's try that. Our parse line, create it for us, please. And let's open up the instruction parser code. We've got our parse line. This takes a line, and once again, as has been the way for almost all of the puzzles so far, irregular expressions are going to come into play. But I'm going to, you know what? No, it's going to be, I'm going to do this entirely with regex. Sounds good. So we'll do preg match, and put in our pattern, our line, we'll get our matches, and I'm going to come back and do the pattern in just a moment, but we're going to do a return, and I'm going to use name capture groups in the regular expression. So it'll be matches, and then the first one will be operation, and then matches start, x matches start y matches end x and matches end y. Okay, so right, this doesn't work yet, but that's the easy part. I know that I want to put them in matches. Now I need to do the somewhat harder part, not terribly hard part of figuring out my regular expression. So the way I would do this is go back in, copy a line of this, and we'll come back over to the instruction parser, and I'm going to paste this here just for reference so I can see what one of these looks like. So we're going to have a capture group. That's going to be the operation, and it's going to be on, and then we're going to have a capture group. That's going to be our first digit, second digit, through, third digit, fourth digit, right? So the digit ones are pretty easy. There's going to be \d plus, which is going to give us one or more digits, and I'm going to paste that little bit in there. And then our operation, right now the only thing our test is caring about is going to be turn on. And actually, no, it's not on. It's not turn on. It's our operation. So let's get rid of on, because turn on is our entire operation. Through is our only thing that we're throwing away here, and it's just a separator between the two groups of digits. And we'll run it, and it says undefined index operation. And so the reason why this is happening is because I haven't done name capture groups, so we need to do that. We'll do question operation, and that will make whatever it captures here, so in this case turn on, show up as operation. So if I run it again, I'm going to get a different failure, and that is going to be undefined index on start x, undefined index on start x, so we need to put that in place. So we'll do start x, and I'll copy that, come over here, start y, and we'll put it over here, and we'll go end x, whoops, end x, and y. Okay, so now all of these should have name capture groups, so this should work. And we got not quite what we wanted. I do know the reason for this, but I'm going to show you how you can find this. So I'm going to turn on verbose mode when I run phpspec, and it should show me what the difference is. And right here it says, here's what I was expecting, but here's what I got. And the difference here is that it's expecting integers, but instead it got strings. So in this case, we want to just go ahead and cast those over to integers. We could also tell it I don't really care about strict typing or whatever, and use a different matcher called should be like, in which case it would not complain. But now it's all happy, and we have a working grid, and a working light, and a working instruction parser. So we need to make a thing that takes the parsed instruction from our instruction parser and passes it into the grid. We could pass the grid into the instruction parser and let the instruction parser do that, but in this case I think I'm going to just go ahead and put it together in the puzzle. So we'll describe the puzzle, because I have a feeling, I don't have a timer on this, but I have a feeling this video is already running a bit long. I need to describe that. So I apologize for the not shortitude of this video. If it is already long, I suspect it is, but we should be nearly done with this one. So we're going to invoke, or make an invoke, and now we've got our new function after we put in public, and we're going to make a grid. Actually, we're going to make a light. So make a light equals new light, a grid equals new grid, and this time it's a real grid, so it's going to be 1,000 by 1,000, and we're going to pass in light so it can clone that in there. We're going to get our parser is a new instruction parser. Looks like I'm using the same names for classes for different days. Fun stuff. And now we need to get our input, so we have input equals File will get us everything in an array. I'll do dir. Go up 2 directories, input, day 6, input, .text. Now we're going to loop over that as line. All right, and now, so we're going to get back a set of instructions from the parser every time we run it, and we need to pass that into the grid. And then at the end, so I'm going to just make a note here, parse instruction pass to grid. And then once we've done our loop, then we need to get the number of lights from our grid. Grid get lit light count, and we'll echo that out. We'll say total lit lights lit, oh, number of lights. It's right there, 2 lines above. Some new lines to make it look pretty. All right, so parse instruction. Parse instruction. So we've got our parser. We're going to get our commands. I guess that's not a great word for it, but it'll work for now. Our parser, and it only has parse line. We'll pass in the line. Nope, the line. And we want to call our grid, our bit from grid. So we'll do grid, and we'll do operation, and commands 0, commands 1, commands 2, 3, 4. All right, with that in place, if I look at my puzzle, it says that my answer was 569,999. So let's see if we've done this correctly. So we'll run day 6, puzzle 1, and it explodes. So we've got a method name must be a string on grid 49. So I've messed up something. Grid 49, method is that, method is that. All right, do we have any more informations? We got nothing for this operation. Oh, you know what? We weren't done. Sorry, I was not done. I have not finished my instruction parser. My instruction parser is super amazing awesome as long as my instructions consist of nothing but turn on instructions, which is not everything that it will be. So let's go back to the instruction parser and let's finish that because I didn't finish it. So I thought I was done. I was not. That's why everything exploded. So we'll do it can parse a turn off line, and it can parse a toggle line. All right, so I've showed this before in other videos. When I run the spec, I get these yellow ones. These are pending examples, stuff that has not been written yet. But let's go get a turn offline. So how about this one? And we'll go back to the instruction parser. Nope, the instruction parser spec. And paste that in. We'll do line equals that. And this parse line should be this array, and the array should be turn off and 487 and 20 and nope, not 20. I'm looking at the wrong lines there. 286, and after 286 it's 540, and after 540 328. Put in a semicolon. Let's change the spelling of parse line so that it says parse line. And we'll run that, and that will fail because we haven't done that. I'm going to go ahead and put in the other test real quick as well, even though I know I've already got a failing test, because the solution to these is so close that it's not going to matter a whole lot for me. So let's do line equals toggle, and this parse line line should be an array, and that array should be toggle, followed by 247, followed by 874, followed by 840, followed by 955, and semicolon. Alright, good. We have two broken tests. Let's fix our instruction parser. We'll go back in here, and instead of looking for just the word turn on, I'm also going to be looking for turn on or turn off. I will go ahead and run it in one shot. This should fix one of the tests, and it does. And then we put another pipe and say you can also look for the word toggle, and whichever set of word or words you find, that's what goes in there. That makes everything run and work. And let's get our runner. Alright, so our number of magic happenings was 569,999. We're running right now. If the simulator is working properly, then we should get an answer of 569,999. This does take a while, and it takes a chunk of memory because we're using 1 million objects in PHP right now. We could certainly have done this in a much simpler way, not using object-oriented programming, just keeping track of a grid of booleans or something like that, which we sort of are, except we've given it some nice operations of being able to toggle itself and have its own behavior. This is taking a while, though. Hopefully it'll finish here soon. If not, then I'm going to go ahead and pause if it doesn't finish here in just a second. And there we go, 569,999, just in time, just before I decided I was going to pause. All right, so that is part one. And I think I'm going to go ahead and end part one and then come back and do part two as a second video because I'm pretty sure this one's already pretty long. Thank you very much for joining, and we'll see you shortly for part two, I hope.